So today we're going to cover YUI Storage Utility. We're going to cover what we did, why we did it, and how we did it. And the URL at the bottom, developer.yahoo.com/YUI/storage, is where you can find a lot of this information about the storage utility and some of what I'm going to talk about today. So just real fast, Eric introduced me, but a little bit about myself. I've been developing in the UI for over 6 years. I've been blogging for 3 years. Majority of that is on JavaScript, but it's all about web development. I'm primarily a developer. I do a lot of hacking and consider myself a bit of a code monkey, and that's where my expertise is. I do a little bit of design, but that's not my forte. These are just a few companies I've worked for over the past 6 years. The last 3 years have been spent at mint.com. It's where I've done most of my work. So what is the storage utility? Well, first of all, it's a place you can store a large amount of data client-side. And it's a cross-browser solution for HTML5. They introduced the new element or properties in HTML5 that allow you to store information on the client side. But each browser has a little different flavor of it, and so we take care of that as one of the features of storage utility. And the bigger part is there are a lot of browsers that do not yet support HTML5, so we take care of that as well for you. And why did we create storage utility? Well, the browser objects are not necessarily easy to use or easy to extend. So our utility allows very simple use of the storage objects, and they're also very easy to extend or add your own engine down the road if you so choose to. These are the storage object. Kind of one of the main drivers in HTML5 was we needed to place a non-cookie space that we could store information. Cookies are sent on every request. That's bad. And it limits the amount of information you can store client-side if you're doing that. So that's one of the things that HTML5 is trying to address. And that's one of the things we addressed with the storage utility. And the two new properties introduced in HTML5 is document.session storage and document.local storage. The differences between the two, session storage will clear after the session ends, so when the browser closes or whatever else is used, that's when the session storage data is removed in HTML5, whereas local storage will last indefinitely. So this just takes a look at the browsers that are supported, that are currently supporting HTML5. You have Internet Explorer 8, you have Firefox 3 Plus, and Safari 4. So the big takeaway here is we needed a utility to simulate storage in browsers that do not support HTML5, since the majority of browsers don't. The second thing, not all browsers are created equally, and there are issues with both Firefox 3 and IE. First, to address the IE issues, IE by default, when writing to and from the storage in HTML5, it's going to be asynchronous. Our utility is synchronous, so we needed to, under the hood, we decided to force synchronicity by using transactions, which is a feature that IE introduced. And then in Firefox 3, so 3.5 has both these issues fixed, but for some reason in 3, they didn't add the clear method, so we implemented that for you. And the way they return values in Firefox 3 is slightly different, and we masked that for you as well. So we needed a tool to handle the cross-browser variations of the HTML5 storage utility. So who should be using the storage utility? This is just a very simple mock-up of what the typical web page is like. So you have your client. They're going to make a page request, which goes to the server, and it's going to respond. And now in the Web 2.0 area, you have a lot of AJAX data or other methods of retrieving data that's just being sent back and forth across the wire. A lot of pages, a lot of sites will keep fetching that same data over and over again. Why do that? It wastes server cycles, and it's wasting bandwidth across the wire. Storage Utility aims to alleviate that. So basically anybody who is writing an application that needs to be high performance, uses lots of JavaScript, and the data that's being sent across the wire doesn't have to be secure. A couple examples of that are if you had an e-commerce site, you wanted the user to enter a zip code, and you wanted to get the city-state back, you could store all those keys client-side so you didn't have to fetch that data from the server. If you were using a service like Flickr or Delicious, there are a lot of tags, tens of thousands of tags, could all be stored client-side for autocomplete. And username, so with email or Facebook, you have a lot of usernames, your friends, just other members. If you wanted an autocomplete or a search feature, you could very quickly use client-side storage to be able to retrieve those usernames. But just as a caveat, the data isn't secure. There's a couple of reasons for that. First of all, it's all stored in JavaScript. So any attack that might expose your JavaScript or any browser plugins will be able to access the storage. So just keep that in mind. Second, it says some, but really all the engines, in one way or another, store information on the client side or on the end user's machine. That's going to be in the browser. It's going to be using the Google Gears database, or it's going to be in a shared Swift object. But all of them store information somewhere on the hard drive, so anybody in the know who has access to that hard drive will be able to retrieve this information. And secondly, as Nicholas Zakis pointed out, if you were to have a situation where you're opening the same website in multiple browsers and it's a private website like an email service or something, and all your messages are stored client-side, you could potentially close one browser, log out, or one tab, log out, think that you've ended your session and that your data is gone, but you've left this other tab open which has all your information in there. Down the road, somebody could come back to that machine and all your private information is stored there. So again, this utility is really good for storing information client-side, but it should be non-private data. And for the rest of the presentation, all the storage classes, utility classes, are all attached to yahoo.util. And we will be omitting that for the rest of the presentation just to save space in the pseudocode. So for example, yahoo.util.storage is just storage, and yahoo.util.storage will just be storage manager, etc. This is just a quick flow chart kind of as an overview of what's happening with storage utility. So as a developer, you're going to call storage manager get function. You don't even need to pass anything to it. It'll just grab the first available storage engine, and then it'll grab the first engine, and then it'll return it to you, and you can go ahead once it's ready to start reading or writing from that storage engine. When you do read and write from that storage engine, there's going to be storage events that are fired. Or there's one storage event. It's a change event, and we've created a storage event object to mirror HTML5 storage object or storage event object that will be returned in all the callbacks. So a very simple example. Here's calling storage manager get. You're getting an instance of a storage engine. Down the road, you can set an item. So this is a key, and this is the value here that you want to set. That's going to be stored into the storage engine. And then later on down the road, you want to retrieve that item. So again, you just pass in the key. And here's an example. I'm going to have this on my website tonight as well if you want to take a closer look at it than what we're going to do here. But this is an example. It's going to store the city and state by the zip code. So if you took all of the zip codes with city and state information of the US, you're going to have about 2 megabytes of data. The example I'm going to use is only going to use the 90,000 plus zip codes. That's everything on the West Coast. And that's only about 200K of data. All the zip codes are going to be stored So the key is going to be the zip code, and then the data is going to be the city, comma, that should be state. And then to retrieve it, you'll just call get item with the zip code. So in the example, the end user is going to enter a zip code, and when they do, we'll retrieve the city and state for them. How are we going to do that? First of all, we're going to get the first available storage engine. We're just going to call storagemanager.get. It doesn't matter which engine I get, just that I get one. Once you get a storage engine instance, you have to subscribe to this custom event ready. Some of the storage engines need a second to kind of set themselves up. That's what subscribing to storage engine ready ensures, that all the engines have been set up. And in the example, once the callback happens, there's one button on the page, and we attach a listener to that button in the example. And then when the user enters a zip code, what's happening in the event callback? Well, first of all, it's going to check the storage.length. So this is the instantiated storage engine, and it's the length of it. In all the storage engines, there's a length property which indicates the number of keys that have been stored there. So in this example, we assume if there is a length, that all the keys have already been added to the storage engine. And it'll just return the value and show it to the user. However, in this example, if you don't have any length to your storage engine, we assume that the keys aren't there, and we make a request via AJAX to go to the back end, fetch the data, and push it into the storage engine. So this is a good example of where you can use the storage engine to mask AJAX, or to store AJAX data, so that you don't have to keep requesting it from the server. So when you call storagemanager.get, there are three arguments you can pass in. The first argument is engine type, and this is your preferred engine type. It's going to be the first one that's tried if you pass in this optional argument. And there are the three different types of engines you can use. You want to pass in the engine name, which is a constant attached to all of the storage engines. The second is the location. There's the local or the session storage. These are constants on Storage Manager. And so if you can specify whether you want it to be stored temporarily or indefinitely. By default, it's going to be stored in the session. The last argument is a configuration object. There are three things you can define on the configuration object. The first is the order. If you don't want to use the default order that we're going to use for you so the get method is going to try all of the available engines until it finds one that works, and there's a default order for that. It's actually the order that they were registered with Storage Manager. So it's really the order they appear in the code. If you don't like that order, you can pass in an array as the order property, and that will be the order that they're attempted first before using the default order. If you only want to use this first parameter engine, you only want to use that engine, you can pass in you can set force to true. Setting force to true means that it's only going to use that preferred engine type that you passed in, and anything else is going to fail. And lastly, the configuration can have an engine property. Currently, this is only being used by the storage engine Swift, and that's because the Swift has a lot of properties that can be customized about it, such as attributes, the ID you want to set up the Swift in, whether you want it to be compressed or not. All that can be passed through this engine property. And right now, only storage engine Swift is using it. So I mentioned that there's a default order that the engines are all attempted. This is the way they appear in the code, but it's also been, the three that we have, we've kind of thought through why we want it in this order. The first one that's going to be tried if you don't pass anything is HTML5. It's the most future-looking engine. Most browsers will begin to start to support that, and down the road, I think all browsers will eventually support these storage objects from HTML5. So we want to try this first, and we want to store it here first if possible. The second one we're going to attempt is Gears. The reason Gears is going to be attempted second, it's a little bit more robust than Swift. It's a database that we're storing information into. but it's not as widely available as Swift. And the last one we're going to try is the Swift engine, and this is because it's the most widely available technology, so it makes a great fallback. The first, so now we're going to take a look at each of the engines and exactly what they're doing. The first engine attempted is the storage, or the HTML5 engine. It's going to use the built-in HTML5 support. This gives you 5 megabytes of storage in Firefox and Safari, and 10 megabytes of storage in IE. Since we're going to, most applications should be built for the lowest common denominator, we're going to recommend that you only store up to 5 megabytes of data if you're using the HTML5 storage. And one other caveat, if you're using session storage and the browser crashes, only Firefox 3 is going to recover that data. All other browsers, when they go into their recovery mode and come back, they're going to lose that session data that was stored. And lastly, the HTML5 storage engine handles all the cross-browser issues of HTML5, the different storage properties. So the Gears engine, there's a lot more to this one. The end user, first of all, has to have Gears installed on their browser. It's one of the biggest caveats to why Gears engine isn't widely used. The second, to use the MySQLite database in the Gears engine, the end user has to approve your program's access to that. So they're going to be prompted. They're going to be prompted for approval to be able to use the MySQLite database. So that's another roadblock to using the Gears engine. Gears uses MySQLite database on the back end to store data for us. And there are caveats to the MySQLite database. It has limitation on database size, table sizes, limitations on how much data can be stored per row, and how much data can be sent in a request. What this all really means is there are some large requests, so large data, data over 10,000 characters has to be fragmented across multiple rows in the database. As a developer, you won't have to worry about that, but that's what's happening behind the scenes with the Gears engine. And one other thing, so Gears and Swift as well, they don't handle the concept of session versus local storage. So to be able to emulate that, we've chosen to use cookies, and we'll check for a story or a session cookie for the storage, the session storage, and we just assume with the local storage that it doesn't ever expire. And lastly, with Gears, the developer has to include another JavaScript file on their page, and that's the Gears init file. And this sets up the Gears namespace and kind of hooks in with the Gears engine behind the scenes. And now the Swift engine, this is the last one we try. And the reason is, according to Adobe, 99% of browsers have Flash not only installed but enabled, so it makes a great fallback. Most people will have this. With Swift, you can store up to 100 kilobytes of data before the user has to approve it. Once you exceed that limit, we'll show the user a dialog inside the Swift object itself where they can approve additional storage. And I believe the limit there is the 1 megabyte of data.
It's actually unlimited.
It's unlimited now? Okay. Loading the Swift takes several seconds. It has to first fetch the Swift from the server. Then it has to take a look at the whitelisted URLs that can actually use that Swift. All of this takes a little bit of time. It's why we have the ready event with all of the engines. To make sure that the engines are all ready to be used, we have used the ready event. So it's called after the constructors have fully initialized, and Swift was the main reason we had to do that because it takes a little while for it to set up, and we've just emulated that across all the other engines so they have the exact same API. Again, cookies must be used for session storage. With that, you now have everything you need to be able to use the storage utility. I'm going to go into more detail now about how each one of these engines work, but that's all you need. You call storage manager.get, you get an instance, and then you can read and write from it. That's the basics of it. Under the hood, there are 7 files that make up the storage utility. The first is storage manager. This is where you register new storage engines or you fetch an instance of a storage engine. There's a storage event. This is modeled after HTML5 storage event, and it will be used anytime you read or write from the storage engine. There's 2 interfaces that are implemented by some or all of the storage engines. The storage interface is implemented by all the storage engines. What it does is it exposes the public API that you as a developer will be using. It's going to have the get item, the set item. All of the public events that are very similar to what HTML5 has are going to be on the storage event, or the storage class. And then it'll also have protected methods that need to be implemented by each of the engines. Now, the storage engine keyed is also an interface, and it's been implemented by the Swift and Gears engine. And what it does is it handles the management of all the keys. It mirrors it in the JavaScript code to make it faster and easier to fetch and evaluate if certain keys exist. And then the 3 engines, the HTML5, the Gears, and the Swift. So we're going to take a look at the register function of Storage Manager. And what exactly is it doing? So register is called at the very end of a engine of a file container, or the code that defines an engine. And what you pass into register is the constructor. And the validation inside register is first going to figure out, does the constructor that you pass in exist? It's going to then see, does the constructor have an isAvailable function? IsAvailable function is used by the get method to see if the technology required to use this particular engine is available, and it'll be called each time before get is able to return an instantiated object. And then engine name is the unique name you're going to assign to this engine, and it's used for a map in the to very quickly fetch when calling the storage manager get. We use this engine name map so that we don't have to iterate through all of the storage engines all of the time. And the map that's created is just the registered engine map, and that's a map of the engine name to the constructor method. And then we also create an array of all the engines that were successfully registered here. And this function will return true or it will return false depending on whether it was it validated and was added to the registered set list. Now, so once you have you have all your engines registered, you can start using Storage Manager Get. With Storage Manager Get, it's going to attempt to instantiate the engine that you provided first, and that's the engine type here. And that's the first argument you would pass in. That's optional. You don't have to provide it. But if you do, we'll first try to use that engine. If that engine is unavailable, the second thing we're going to do is see if you set that force configuration property. And if that's true and your engine wasn't initialized, and it's going to fail. It's going to throw an exception. But if that's false, then we go ahead and we're going to try first to use the configured order. We're going to iterate through that order and see what engines are available to use, and we'll use that first. If you didn't define the order, then we just use that registered engine set that you saw in the registration function. And it'll just iterate through that, see which engines are available, and return the first one. And when an engine is successfully instantiated, we return it. Otherwise, we're going to throw an exception. And since most browsers support, most people are going to have either one of these technologies or the fallback technology. 99% of browsers have Swift or Flash installed. There's a 99% chance that this is going to work, probably a little bit higher than that. So the next object is the storage event object. This is mirrored after the HTML5 storage event object. So it has all the same values that that object has: the key, the old value, new value, URL, window, and storage area. Those first few probably explain themselves. The storage area is going to be a pointer back to the storage engine that was used to generate this event. And the storage event will be passed into all of the subscribers to the storage, to the change event of the storage engine. So once you have an instantiated engine, you can just use the subscribe function, pass in a callback, and the callback function will be passed a storage event. And lastly, the only thing we've added to storage event that wasn't there originally in the spec is we have added a type. This lets you know, was the change event, were you adding data to the engine? Were you updating existing data in the engine? Or were you removing data from the engine? And this is so you as a developer, if you need to respond to certain types of events, you have that metadata available to you.
Does this work across Windows? So you have two windows and you store it in one window and it triggers another window?
We haven't tested it in that environment yet. I think, well, this is going to be a pointer to the current window that it was executed in, so there could be conflicts if you're passing it between different windows right now. So then to take a look at the interface, the storage interface, it uses the event provider model. What this means is you get the subscribe function, you get the unsubscribe function, you get all the goodness of the event model of YUI2, and it's going to be applied directly to all the instantiated storage engines for you. These are the public functions that are spec'd out in HTML5, and all of them exist with all of the storage engines, and storage is what handles it. We have added one new function, and that's the getName function, and that's going to return that constant engine underscore name that was defined when the constructor was created. And this just allows you to be able to tell what storage engine you have. And lastly, the storage has a bunch of protected functions as well. These are actually the functions that are going to be implemented by each different engine. And the reason we do that is the public functions can handle some of the generic, when you set up storage events, when you evaluate if the arguments passed in are valid and whatnot. And then you can, once you have, you have valid keys, you have valid content, you can then just go ahead and pass that into the protected function, which is going to do the reading and writing from whatever technology we're using with that engine. There's one other thing we did that's not in the spec, and that's this create value and get value. We decided down the road as we were developing this project that we wanted you to be able to pass in non-string values. So we wanted you to be able to pass in numbers. We wanted you to be able to pass in Boolean values. And when you called the get method later, we wanted those values to return in the same primitive type that they were passed in. So before delegating to the protected implementation functions, the set item is going to call create value, which is going to add some meta information about the type of object that was passed to it. And before the get item returns, it's going to call get value on the value that the engine returned and convert it to whatever meta type or whatever type was originally provided. So this is kind of complicated. So just to reiterate, with the developer calls set item, what's going to happen is it's going to parse the parameters, it's going to handle any errors, it's going to set up the storage event that's going to go to the callbacks, and then it's going to, if all that works out correctly, it's then going to call this protected method underscore set item, and we've done this for all of the methods, and the underscore set item has to be implemented by the engine. And that's how the model is. So there's the public method, and then there's a protected method. All the protected methods need to be implemented by each different engine, and that way we can have a common API exposed, and each engine, we can delegate to for the actual reading and writing from their technology. And there's a couple events that are important. The custom event ready, this is the name of the event that we'll be using to tell you that the storage engine is ready. So after you've instantiated a storage engine, subscribe to this with a callback. Once that callback fires, you can go ahead and use that engine. The change event here, this is what happens anytime you read or write from the engine. This is when you're calling set item or if you're calling remove item. The set item can either add or update an existing key, and the remove item will just remove a key and its value from your engine. So taking another look at storage engine key, what is it doing? It's just handling key management. It's a uniform place that we can store the keys, we can fetch them, we can see if they exist, and this alleviates having to go to the engine all the time or the underlying technology all the time to see if a key exists. And this is currently used by the Gears because Gears has everything stored in a database. So rather than have to query the database to see what keys anytime I want to work with it, I want to have those keys readily available. And second, it's used with Swift, although Larry Cole put a lot of good work into the Swift during version 2.8. All the keys used to be stored in an array, which was why we had to store the keys in the JavaScript. That's no longer the case, so this probably isn't necessary with Swift anymore and might be one of the future improvements. So looking at each of the storage engines, what do they have in unique? Well, they all have the protected methods that have to be implemented. They're all going to have an underlying technology. For the terminology's sake, we've called this technology the driver. So, with the Gears engine, the driver is the Gears. With the Swift engine, the driver is the Swift. All of them are going to call the ready event when their constructors finish. Each of them have to define the engine name constant and the isAvailable function. All of them are going to have a length attribute, and this is going to be the number of keys that are currently stored in this engine. And the last thing they need to do is call storage manager register so that it's available to the get function of storage manager. So looking under the hood of HTML5, this is the unique name we've assigned to HTML5 for the engine. The isAvailable function, to see if we can use HTML5, all it's going to do is evaluate if document.sessionStorage exists. We assume if document.sessionStorage exists, that you can use the HTML5 engine. With HTML5, each instantiated object stores the driver on the object. This is because there are two different singletons, the local storage and the session storage objects. And so each driver needs a pointer to that object. And it's just going to, anytime there's a set or get or any of the methods, they actually just defer to the HTML5 method with the caveat of cross-browser issues. So, Firefox 3 doesn't have a clear method, so we go ahead and implement that. And we handle we make IE8 behave synchronously, so it behaves like all the other browsers. So the Gears engine, we've just named it Gears. Its isAvailable function is a little bit more complicated. The first thing we need to do is see if the Gears namespace exists. This happens if you include the Gears init function or file, and that file finds the Gears API. The second thing we need to do is we need to write to the MySQLite database. The reason for that is that will force the user, if they haven't already, to see that dialog to either approve it or to deny your application's access to the Gears database. If they choose to deny access, it's going to throw an exception inside this method, and we can return false. Otherwise, we return true, and we assume that it is available. A few other things about Gears. It's going to create a database in MySQLite called YUI.database, and it's going to create a table called YUI Storage Engine. So if you guys are using Gears for any of your projects, don't use these names. And lastly, with any database, you need to close your connections to it. So what we're doing is, with the Gears engine, when the window unloads, we go ahead and we close any of the database connections that we've opened with Gears to release the resources. Now, how does the Gears constructor work? First of all, it's going to initialize a driver if it doesn't exist. What that means is it creates the database or accesses the database and sets up the table or just makes it available. The second thing here is really important, and another reason why you don't want to store secure data. It's because there's no way really, or not an effective way to know when the session has ended. You can tell if the browser window is closing, but you can't really tell if they have another window open. So rather, with the session, the data stored in Gears and Swift in the session, we don't have a really good way to know that the session has ended until they come back again later and that session cookie doesn't exist anymore. So even though you've stored information in the session, it's actually going to remain stored on the machine until that user comes back the next time. And when they come back, we evaluate the cookie. We see that it doesn't exist. And before the engine is returned to you, we're going to clear out all those previous session values. But those session values they're not like the HTML5. They're not truly session. They're actually stored until the next time this same user comes back and this engine is used. So we also, with the Gears, we delegate to storage engine keyed to queue up all of the keys and put them in a place that's available to be able to use in the JavaScript. And we update the length, and we call the ready event. Anytime there's data that needs to be read or written, it's going to delegate to Gears, which is going to read or write to the database. And any data that's over 9,948 characters, the database can handle up to 10,000 characters per query. And when you add in the insert statement and whatnot, that leaves 9,948 characters available to us. So anything that's larger than that has to be fragmented, as I mentioned earlier. And when we return the data to you, we'll put all those fragments back together. So you won't have to worry about it, but that is what happens behind the scenes. So the last technology is the storage engine Swift. And what this is showing is just there's this shared object, and all Swifts have the availability to read and write from a shared object, and you just have to namespace it. And we've called it SWF. The is available function for Swift is pretty simple. First of all, we make sure that Yahoo widget Swift, this is the Swift utility, exists. And the reason we do this is we're going to use this to instantiate the Swift object and be able to get the Swift back to read and write from. And the other thing, we need to make sure that at least Flash version 6 is defined. That's when Flash introduced this shared object, which we're going to be using to read and write data. And it uses the shared object technology of Flash. So as I was saying, the driver here is going to be an instantiated Swift widget. There's a lot of parameters that can be customized here. Do you want to compress? What ID do you want the container to be? Do you want additional attributes applied to the Swift object? All this stuff can actually be passed using the configuration configure.engine that was passed into the get method. So if you expect that you're going to be using a Swift, or when Swift is used, you want particular properties to be used, you can pass those through the storage manager get function. And the last thing is we compress all the data by default. And the reason we do that is it just gives you more space to be able to store into the Swift object than the allocated 100 kilobytes of data, or I guess now it's unlimited data. So the constructor for the Swift, what's it going to do? It initializes a driver. That's going to instantiate the Swift object, which will go out and fetch the Swift object. when that's ready, it'll fire the Swift ready event, and then we can use the storage engine keyed to queue up all of the keys onto the JavaScript side. We can clear any session cookies that existed from before. We update the length, and we'll call the custom event ready. Any time we're calling get item or set item or just using the engine, it eventually delegates down to a comparable method that's in the Swift store Swift. And anytime you exceed the 100 kilobytes of data, or at least the first time you exceed it until the user approves unlimited data, you'll see the user will be shown a dialog box asking them to approve additional data for the Swift storage. I was going to show you an example of how to write cookies, or how to write a storage engine using cookies. They're a pretty simple technology to illustrate, but I'm running out of time, so I'm going to skip it. This is available on my website, mattsnider.com. Here's a good example. You see this engine is implementing the protected clear method, the get item method, the key method, the remove item method. All these, anytime you're creating your own engine, you just need to implement, there's 6 methods that need to be implemented. So where is storage utility going? What's the future of it? One of the things I think that is going to happen down the road is we'll probably end up combining the Swift Store.js that was written by Larry Cole and my storage engine Swift. There's a lot of similarities in the code between the two and a lot of redundancy that doesn't need to be there. One of my grievances with what I wrote is that the way the ready event works is a little hand wavy right now and kind of a little hackish. And I'd like to improve how that works down the road and make it work more the way that I expect it to work. So you'll expect some improvements with the ready event. And in the original implementation, with the use of any class that inherited from storage engine keyed, they didn't really make a good use of that inheritance. And I have since fixed that and checked it into GitHub, but it's not in the the release candidate version of storage utility. But there's been some improvements made in the way that we inherit from storage engine keyed. One possible improvement that I think we'll do, we'll either have a new set of engines or augment the existing engines to be able to support asynchronous callbacks. One, this alleviates even the need to have the ready event. And 2, it allows you to use technologies that are, by their nature, asynchronous. And a good example of that is Browser Plus. So Yahoo's Browser Plus technology is every call is asynchronous. And because the utility is all synchronous, we can't use it. And the second is, if you wanted to use storage engine as a front for all your AJAX requests, where you're just fetching and retrieving data from the back end, you could potentially write a driver based on AJAX and use all the goodness of this engine. But you can't because it's asynchronous. And lastly, we really hope to have your contributions, and with the gallery and the availability of storage utility in the future, we hope that all of you will find ways to improve what we've already done. You can, there's the yahoo-library.com contribute URL. You can go there and figure out how to contribute. It's actually really easy. Yeah. That's my presentation. Do you guys have any questions?
Yeah, my question, I mentioned some of the different engines have different storage limitations, 10 megabytes for IE8. Is there a way of determining how much space we have available?
So the question was, is there a way to determine with a given engine how much space is available? The short answer is not really. with some of them, like the HTML5, you can guess, you can look at how much data you've stored and how much data should be available and determine that. With the engine like the Swift, we don't really know until you write to it that it's out of space. You could do the same with gears. So we could expose APIs with the gears and probably the HTML5 that gave you an estimate of how much space was available, but we can't do that with the Swift right now. And because of that, we chose not to enable that. They just throw an exception when you can't write to them anymore.
The Swift in particular is probably a security thing that they
Is that why they do it?
to not let you know how much is available.
Okay.
So they probably won't change that.
Any other questions?
What are you guys using the storage utility at Mint for?
The question was, what are we using it at the storage utility at Mint for? And the answer is currently nothing. I just recently wrote this back in August. Mint was recently acquired as well, and we've been moving so fast that I haven't had time to implement it. What I think we're going to do with it is there's one place where we do this zip code lookup. I think we'll end up putting that in the storage utility, and the other thing is every user has a set of categories. There's shared categories among all users, and then there's unique categories for users. I would like to put that in the storage utility, which will improve our autocomplete and improve some of the other features, but it's all down the road and hasn't been implemented yet.